Alright, hi guys, and welcome to the e-learning of direct proportion. Now, before I introduce this concept to you, I want to share with you a story. Now, imagine you are someone who is walking along the road, and in the first second, you travel about 3 meters. In the second, you travel another 3 meters, making your total distance 6 meters. And in the third second, you travel another 3 meters, making your total distance 9 meters. What do you notice as time increases? You will notice that as time increases, the distance that you ran increases as well. And that is actually the main concept behind direct proportion. So what exactly is direct proportion? Two quantities are directly proportional if an increase in one will cause an increase in another at the same rate. Alright, now we're going to take a look at this how this actually looks like in terms of the graphical representation. Alright, so same person, you would know that if you actually return a book late to the library, you will actually be fined for it. So suppose there is a library that charges a fine at 50 cents per day. 15 cents, sorry. So on the first day, you have accumulated 15 cents of fine. And on the second day, you have accumulated another 15 cents of fine, making your total fine about 30 cents. And on the third day, you have accumulated another 15 cents, which makes your total fine 45 cents. So let's try to look at how this would look like in a graph. So letting X be the number of days that the book is not returned and Y be the corresponding accumulated library fine, you would see that as you plot the graph, a straight line would appear. Please plot this graph and draw the straight line on your worksheet. Alright, so can you find an equation to represent this relationship between X and Y? Okay, think about it. Think about what you have learned before in straight lines. Alright, so you would know that as we see from the graph, when there is an increase in one day, there will be a 15 cents rise in the fine. And as we increase in another day, another 15 cents, another day, another 15 cents, and so on and so forth. So you notice that the step size are all equal, which means that there is an increase at that same rate. So we will know that as X increases, Y increases at the same rate. And what is this rate? This rate can actually be found by finding the gradient of this straight line. So picking 2 points and finding the gradient, I would find that actually the gradient is just 15. And it's not surprising given that for every day you do not return the book, your fine actually increases by 15 cents. Okay, so this is our conclusion. If Y is directly proportional to X, then the graph of Y against X is a straight line that passes through the origin. Okay, and since we've already found that the gradient of this line is 15, using the equation y equals to mx plus c, we would know that the equation of the line is y equals to 15x. Okay, so this is the graphical representation of direct proportion. Now let me challenge you a little and ask you, do you think it is possible for y equals to x squared to be a straight line? Meaning, do you think it's possible for y to be directly proportional to x squared? Now, it seems a bit strange that y equals to x squared can be a straight line because we know that y equals to x squared actually is a smiley face curve, isn't it? Okay, so this is the graph of y equals to x squared where the vertical axis is y and the horizontal axis is x. So from the graph, we know that y is not proportional to x. Why? Because as we have mentioned earlier, if y is directly proportional to x, then the graph of y against x is a straight line that passes through the origin. But we know that in this graph, the graph of y against x is not a straight line that passes through the origin. But what do you think will happen if I change the axis of the graph? Meaning now I plot y against x squared. So having the table of values and I plot it, oh, you notice that actually I get a straight line if I were to replot y against x squared. Notice that the x's are y against x squared. Okay, not y against x, but y against x squared. So therefore, I can conclude that because the graph of y against x squared is actually a straight line that passes through the origin, therefore y is directly proportional to x squared. So you find that pretty much any two quantities can be directly proportional so long as if I were to plot one quantity against the other, okay, on the axis, I get a straight line that passes through the origin. Okay, so let's take a look in algebraic representation. Just now I've shown you the graphical representation. What about the algebraic representation? If y is directly proportional to x, we actually write this symbol y and then this alpha sign here proportional to x. Actually, the symbol alpha, these two symbols are the same, is read as varies, okay, or directly proportional. Okay, so based on this relationship, I can form this equation y equals to kx, okay, where k is a non-zero constant. Now, I don't want you to worry about this. Okay, this just shows me the two quantities that are directly proportional to each other that eventually still leads to this meaningful equation. Okay, why is k so special? Because k actually represents the constant of proportionality or the rate of change. Okay, so now let's come back to the table form and let's answer this question. Given that x is directly proportional to y, express y in terms of x. Okay, how do I solve this algebraically? Okay, since I know that y is directly proportional to x, okay, I have y equals to kx, where k is a constant, and we mentioned that k is actually the rate of change or the constant, the constant of proportionality. Okay, so what I'm going to do is, because I have this set of values x equals to 2 and y equals to 30, I can substitute it into this equation so that I can find the value of k. Remember, I want to express y in terms of k. So when x is 2, y is 30. So substitute it into this equation. I have 30 equals to k times 2. K equals 30 over 2, which gives me k equals to 15. Therefore, you will find that y equals to 15 over x, 15 times x, or 15x. Would this work if I substituted another two values? Definitely. Okay, so let's try. When x is 5, y is 75. Let's substitute 75 equals to k times 5. Okay, so I get k equals to 15 at the end. So what do you notice in both cases? Did I have to find a value of x or y? No, I didn't, because all I was finding is the value of k. Okay, so for such questions, always find the value of k so that you can see the relationship between the two variables. Okay, so let's answer the second part of the question. Hence, find the total library fine that has to be paid by the 10th day. Okay, so by the 10th day, it means x equals to 10, right? So given this relationship, all I have to do is substitute x equals to 10. Okay, so I substitute x equals to 10, I get y equals to 15 times 10 gives me y equals to 150. And therefore, the total library fine that has to be paid is 150 cents. Alright, so I hope this gives you a good view of how to represent direct proportionality in terms of the graph and in terms of the algebraic representation. Alright, so I'll see you in the next video where we will go through the first 4 examples for practice. Alright, thank you.